Dear students, today we are going to next lecture in terms of the comparators. Already we have discussed the types of comparators, that is the amplitude comparator and phase comparators. So we know that the amplitude comparator works on the principle of that it will compare the amplitude of the two or more signals, and phase comparator it will compare the phase of the two or more signals. So on this principle they are called the phase comparators. Now further we have discussed about the various types of amplitude comparators. The first bridge type amplitude comparator we have discussed in the previous class. Now today next amplitude comparator, that is called the instantaneous amplitude comparator, which we are going to discuss now. So this is the circuit of this instantaneous amplitude comparator, that we have two input quantities, that is the restraining quantity and operating quantity. The restraining quantity is here denoted by S1 and operating quantity is denoted by S2. The restraining quantity is fed to the rectifier circuit, and then this is given to the averaging circuit, and after that it goes to the level detector. Similarly here the operating quantity S2, it is given to the rectifier circuit, and after rectifier circuit it is given to the level detector, and after comparison here at the level detector position it goes toward the output. So this type of comparator is of two types, averaging type or phase splitting type. Here we are discussing about the averaging type. In averaging type, the restraining signal is rectified and smoothened completely in order to provide the level of restraint. This is then compared with peak value of the operating signal, which may be rectified but not smoothened. Peak of the operating signal should exceed the level of restraint for tripping the circuit breaker or giving the tripping output. So here the waveforms are shown here, that this is the restraining signal and this is the operating signal. So what we are doing here, we are rectifying only operating signal with the help of this diagram. See, operating signal is rectified only. So here this operating signal will be rectified, and so this is the rectified value, this is the rectified value, this one half wave form has been shown here, this is the rectified value. Now what about the restraining signal? Restraining signal is rectified and then it has been fed to the averaging circuit so that further it can be smoothened. So here restraining signal has been shown with this dot line. This is the rectified and smoothened signal. So how this comparator operates? Once it will go to the level detector position, then the rectified operating value signal, if it is more than the restraining signal which is rectified and averaged, then this will issue a trip command, otherwise it will have a restrain command. So here the comparison is made between two signals, and this is the output. We can see here at this position and this position the operating signal is more than the restraining signal. Same type here also. So that's why we are getting the output in this fashion. This output is given here to protecting device. That is how this comparator is called the instantaneous amplitude comparator. Now next we will discuss about that is called the sampling comparator. So sometimes it is necessary that we have to sample two quantities. It is required that we have to sample two quantities. As shown here, the sample time, it is convenient to obtain the required characteristics by comparing the amplitude of one signal at a certain point on its wave with the rectified and smoothened value of second signal. In case of reactance relay, the instantaneous value of voltage at the instant of current zero is compared with the rectified and smoothened value of current. So how this sampling comparator works? What he is saying? He is saying that if we have two signals, as we have shown here that we have a voltage signal and we have a current signal, they have been phase spaced by an angle phi. So this voltage signal will be compared with this current signal at this current zero position. So at this current zero position, we have a voltage signal that is V sin phi. So let the phase angle of the circuit be phi. A value of voltage at current zero will be defined as a V sin phi. You see here, this is the vertical line, it is showing the V sin phi. So we know that reactance relay will operate when the value of the reactance will be less than some defined value. Defined value here is with K. K is constant. We can define any set value in place of K, where X is the reactance relay seen by relay and K is the design reactance. So we can define, since X is Z sin phi, just see, this is the operating characteristic of the reactance relay. We have X and minus X and minus R and R. This is the impedance Z. So if you resolve into two components, this will be a X. So this X is nothing but it is a Z sin phi. Just see, X is nothing but it is a Z sin phi. So X is called the reactance. So value of X should be less than some constant value to operate a reactance relay. So what is here? We can write here Z sin phi will be less than K for relay to operate. Or we can write here in place of Z, that is V by I. So we can write here V by I sin phi will be less than K. Or if we change into RMS and average value, maximum value, so we can write here that V max by root 2 sin phi should be less than K times I average into 1.11. Or we can write here V max sin phi should be less than K dash some value of I average. So this is the condition for the reactance relay to operate, and we can design a reactance relay to operate using the sampling comparators. So sampling comparators, what you will do? It will measure the voltage value at the current zero position, and then the reactance value, that is X, is defined with the voltage parameter, that is the Z sin phi. So here, since this is the X value, this X value, so two lines are showing here. This is the origin and this is some line. This means this indicates the parameter of X. So X relay seen by X is less than this value, then only reactance relay will operate, otherwise it will not operate. That is how the sampling comparator works. Now we will see what is the diagram of the sampling comparator. As we know that we have a two signal, current and voltage. So current is fed to the rectifier, then it is fed to the averaging circuit, and finally it has been given to I average. Now this I is passed through zero crossing detector and it goes to the sampling circuit. V is given as input to the sampling circuit. So finally we get the two output here, that is your V max sin phi and I average. Now this V max sin phi will be compared with I average at current zero position. This is the difference block which indicates there will be a comparison of these two signals, that is the V max sin phi and I average. And after that, this V max sin phi minus K average, this is the comparison which will be done here at the difference block. Then after the difference block, we have a polarity detector. So polarity detector will recognize what is the polarity of signal. If the polarity of signal is positive, then this will give a trip command, output as a trip command, and it will be fed to the circuit breaker or relay. This is the diagram of the sampling amplitude comparator, which has been shown here with rectified averaging circuit and zero crossing detector blocks. So this is how the sampling comparator will work. So in this class we have discussed the two types of comparator, that is the sampling comparator and instantaneous comparator. Amplitude, next is the amplitude comparator. So both the comparators are the part of the amplitude comparators. Both are the part of the amplitude comparator. So today's lecture will end here. Further comparators will be discussed in the next class.